All right, on your team. Here we go. So in looking at this, just talking about our switch mode amplifier family, if you will, it's grown quite a bit. And this is the newest edition here with the 9000 series. And you can see the range of what's offered here from DC to 250 kilohertz, and that's where 250 kilohertz covers the 8700 series and now the 9000 series. And if we're in the DC to 50 kilohertz, we've got the 8300, 8500. And then the bottom two products cover up to 200 volts peak, and the top two products can go up to 400 volts peak. So it's a way to sort things out and make sense of some of the differences. And as you see in the top right corner, the 8700 series is our biggest, strongest, most powerful, and most expensive solution. And so you take then the 9000 series, it sits there as our least expensive solution, but yet very powerful. And we'll be looking at its capabilities here. As we think about this, as we start off with the 9100 series, that's our single channel, and it's capable of a lot. We have 5 kilowatts of power in 2U of space, up to 100 amps continuous. It's available in that configuration, and it covers the bandwidth at full power from DC to 250 kilohertz. And you see the drop and rise time, slew rate, and max voltage. And that drop and rise time and slew rate is very fast for a switch mode amplifier. We've got then very low distortion, and the ripple again is far below what other switch mode amplifiers would provide. And the power supply is unique because of its power factor correction. It's a universal voltage power supply, so it covers from 100 volts AC all the way out to 200 volts AC. And single phase, but you can literally plug it into a wall outlet and drive power. It's very unique for an amplifier with this kind of capability. And yet if you run it all the way out to 208 or 230, 240 volt, you can drive it at its full power capabilities. And this power factor of 0.98, 91% efficient in comparison to our linear technology, which might be around 40% efficient. That goes back to what you mentioned, Bob, of that whole linear versus switch mode differences. These operate very, very efficiently, and that's why we're able to squeeze so much power out of a small form factor. So the 9100, or the 9105, I should say, is our first configuration, and it's capable of 4.2 kilowatts, and it can drive up to 35 amps RMS, 50 amps peak, 4.2 kilowatts there for max long-term power, single channel. And if you're just plugging into a 110 volt wall outlet, that's going to have a slightly lower power, obviously, that's produced, but at 208 volts, you can get to that 30 amps of maximum power. So as you see here on a form factor, it's still that 2U of space, but what's happening internally here is we have the power supply, as you see highlighted there in yellow, and then this is an amplifier. That's the amplifier portion, and then over here the input cards. So this is what's built in all of these, all the models, and we'll see how that scales up, and we're able to squeeze so much out of a small 2U cabinet. Moving to the 9110, you can see internally things have changed, and it allows us to get up to 100 amps peak of current. Same power output for the other aspects, still single channel, but as you look here, you can see that we just simply added internally another amplifier. So there's still the power supply, now 2 amplifiers, and the input card for single channel, but we're now up to that 100 amps peak capability. And now we're stacking in a third amplifier next to the power supply, as you see that change. So that's where we get up to 150 amps peak, and same max long-term power. That's a single channel. We were at a power show and had the 9115 available with a clear top on it, And a number of engineers were staring inside and just amazed at that, of just how much was squeezed into such a small space and the kind of power that is available through this 9115 especially. So, but it allows us to offer a scalable solution or configuration, and obviously depending on their price point, what their needs are, and all of that with a very small 2U of space. So now if we look at those three configurations, this is a summary, but this gives you a reference to the differences between. We have, as you see at the bottom, 18 kilograms or 40 pounds for the 9105, very lightweight, and at a max of 50 pounds to the far right, or 22, almost 23 kilograms for the 9115. Still very lightweight for the kind of power that is produced here. So then we take it a step further, and now we start looking at the two-channel capabilities, because the 9205 and 9305 gives us that multi-channel effect. And what's nice with the 9205 is that we're able to maintain 50 amps peak per channel, same max long-term power per channel. And you can see here on the far right that the change in this is that we have not only the two amplifiers, but now two input cards. And that's what is we simply by adding that card gives the additional channel, takes up very minimum space. And then we have our 9305. So now this is obviously loaded out with every bit of space used in this chassis. But same 50 amps peak per channel, 35 amps RMS per channel. We've got the same max long-term power per channel. And with three channels, we see this being used, for example, in small bore low field MRI applications where they have to drive three different axes. They now have a capability of doing so. And we're seeing this sold into different MRI imaging applications. And there's the three input cards providing for those three channels. So that's the layout, but then it gets more exciting when we can begin to scale these as power modules in a power system. And you can see this with 40 kilowatts and up to 800 amps continuous, and the same kind of performance as far as drop and rise time, a very fast slew rate. And then we also are able to, with the voltages, where the individual modules can go up to 200 volts peak. When we put them in this array, we now can, in some applications, depending on the loads, right? But we can bridge up to 400 amps peak. And we're still able to, in that bridge configuration, to put modules in parallel to drive as much as 1100 amps peak or 800 amps RMS out of a very compact system. That's the exciting territory that we've expanded the envelope, if you will, of our performance by putting these in this kind of array. It still provides this kind of performance with the distortion, very low for switch mode amplifiers. The ripple is very low comparatively. Strong power as far as 40 kilowatts in this kind of cabinet system. And you're still using that universal voltage power supply. So it's very flexible in the supply voltages that are available.
So one of the questions is where does this fit? The 8000 series is kind of a laboratory piece. It's got a lot of like current limit and variable output impedance and all kinds of dip switches and configurability and options, and whereas the 9000 series has a smaller feature set, but it also it's a much better dollar per watt. At comparable power levels, the 9100 will go to 250 kilohertz just like the 8700 will, but it is about 25-30% cheaper. So that's one of the things to keep in mind, is if someone is looking to design something into a product and they're needing dollars per watt, the 9100 would be a good choice. Another thing that would cause you to want to talk about the 9100 is if they are in a power constrained situation. It is 91% efficient from AC mains to output. So that's the first thing. Second thing is it's power factor corrected, which means it draws power from the entire 360 degrees of phase versus just at the peaks like a linear supply would. So for a given size breaker, you'll be able to get about 30% more power out of it. Because it's got a universal supply and it runs single phase, it makes a really nice piece for somebody that needs a lot of power in a lab environment or an office environment where, getting three-phase deployed would be really, really expensive. Like our other 8000 series products, when you traditional switch mode amps stop at about 5 kilohertz, and RF amps kind of come down to about 10 kilohertz. And so we kind of live in this 5 kilohertz to, in these case, 250 kilohertz area where people need a lot of current. Will be very, very cost effective. And the 9100 is a 5 kilowatt object. To kind of put that in perspective, it has the same power capability as the 7794 or the 7796 at its ideal power transfer point. And for much of its range, it's actually more powerful than one of those. And it also is 30% cheaper than one of those units. So if you're in a situation where somebody needs an amplifier and they need a lot of power and they don't want to spend a bunch, the 9100 is a really, really good choice. So I'm going to jump now to a new subject. You notice Leander talked about, well, it's 1 amp module, 2 amp modules, 3 amp modules, or 1, 2, or 3 input cards. What we're doing there is kind of leveraging some standard pieces and allowing you to kind of Lego-like put them together in multiple ways. You've got a couple of standard parts that allow you to create 5 different products. So from a service and support point of view, it's not like you've got 5 different products. You've got a product, and it's just how many of what kinds of boards you have in it. So it makes supporting the family, the amount of parts that needed to be on hand and the number of different boards, much smaller than it would be if they were 5 unique products from a circuit board point of view. So for people that are further than Chicago, it has a support benefit. Now, another area where the 9100, the 9000 series will shine is power supply is 5 kilowatts, the amplifiers 10 kilowatts. So they're much closer, and so this makes it a much better choice for applications in, like Leander had mentioned, sonar, where they've got the load tuned, so it's pretty much a real load. The number one, number two, if they need power over a long period of time, your transformer-based power supplies or your linear amps are good at surge stuff, but this will be its surge power and its continuous power are within 5%. So I mean, it's a block of power. We're having a lot of luck with capacitor testing. The big system he was talking about, they needed 200 kilohertz, 800 amps.
Yeah, and almost 800 amps. Or I'm sorry, volts. Almost 800 volts.
Yeah. There is no way to get that kind of power, to drive that kind of a load with anything but a switch mode. If you try to do it with a linear, you're looking at racks and racks of equipment. So you'll be 25% the cost of any other solution. As soon as you get somebody trying to do testing above 10 kilohertz. Where we're seeing a lot of this, we have in England, we've got a couple of systems that went into the E-Formula Racing, where they were testing the various parts of the drive system for basically electric-based race car. What they were doing was, again, high voltage, high frequency, high current, driving it into capacitors. Now, because of the nature of a capacitor, the 9000 series makes a really nice object because most of the time you're dealing with milliohms of impedance. You're just wanting to dump a gobsmack of power in. And so you start to look at that rack system that Leander showed. You can get a significant amount of power in a small package that can run from a variety of voltages, and it doesn't care about line sag, it doesn't care about dirty power. Those are the kinds of places that the 9000 series would really shine.
Also, we're seeing into research, university projects or private research for different, again, inductive or capacitive loads, but there's inductive research going on in magnetics or also underwater, like water tanks, in university research labs where they're doing different applications there. And you think of even just two 9115s in parallel drives, 300 amps peak.
Yeah,
that's crazy in 4U of space. So they really appreciate the power density and small form factor in those lab environments. These are some of the applications for this kind of product that we're excited about, and the configuration possibilities makes it very flexible for all those applications. So let us know if we can help you think through, would this work? Could this possibly? Because we'd be happy to do that.